Hello everybody, hope y'all are doing absolutely amazing. So today we're going to go over statistics 1 on all-in-one A-levels. This video is going to be a little bit longer because I wanted to go a little bit more in depth because I figured out that people struggle more with statistics than they do with pure math or like core math. So yeah, let's dive in without further ado. Please subscribe. Comment down below whatever video you need. I'll try my best to upload it with the time zone you guys would like. And yeah, like the video as well. Okay, anyways, so let's start. Statistics 1, mathematical modeling. Oh, first of all, we're going to go through everything in the syllabus and the specification. I'm going to tell you what you guys need to memorize and what is already in the data booklet. So let's dive in. Mathematic modeling. So it's a simplification of a real world situation, okay? And it has 7 steps to it. So 1, you recognize a real world problem. 2, you plan or devise a model. 3, you use it to make a few predictions. 4, you collect some experimental data. 5, you compare the data against your planned model. 6, you use statistical concepts to see how well the model describes the real world problem. And then 7, if the model did not meet your requirements, then you change it a bit or you refine it. Advantages and disadvantages. Advantages, it's really quick to make, and then it helps you make predictions. Disadvantages, you're simplifying real world situation. That causes a bit of error because model may be too simplistic, or model only works in certain conditions because you're practically not thinking of other circumstances. You're making it oversimplified, so it might not even work. Chapter 2. So the mode or the modal class is a value that happens most often. So if I have a data value of 5 numbers, 4 of them is 1 and then the 5th one is 5, then 1 is going to be my modal class because that value keeps on coming again and again. Middle value, median, oh my god, median is the middle value when you set your data in order. And what we mean by that is smaller to bigger. Or if the question asked you bigger to smaller, and then you find the middle value. So the mean is sum of all your numbers, all your integers, over the total amount of numbers you have. And if you have a frequency table, you just times everything, every value you have, times each of them's frequencies over the total number of frequency. It's very clear if you actually see the table. So lower quartile and upper quartile, what are they? So if I have a data like this, my lower quartile is 25% of that. My upper quartile is 75% of that. It's kinda to give you a better understanding of the whole numbers. Instead of going from the first to last, you go from 25% in and 75% in. So lower quartile is for discrete data. What does discrete data mean? It means you have a counted number. So it's not continuous, it's fixed. So divide n by 4. If it was a whole number, then lower quartile is halfway between the data point and the one above. But if it's not a whole number, you just round it up and that is your data point. Same concept goes with upper quartile, except this is your 75%. So you find 3 over 4 of n. And again, if it was a whole number, your upper quartile is halfway between the data point and the one above. If it's if it's not a whole number, you round up and that's your data point. Range is a difference between the largest and smallest in the data set. IQR or interquartile range is a difference between your Q3 and Q1, so upper quartile and lower quartile. Interpercentile range is difference between 2 values for a given percentile. Variance, this is really important. It's going to be your mean of the squared minus the square of your mean. So mean of all your values squared minus your normal mean, but then you square it. That's also written as SXX over n. So yeah, where SXX is this. So it's your sum of your squared minus your mean squared, basically. So this part that I'm now going to highlight in red is actually given to you in your data booklet. All you've got to remember is to find your variance. You just write your SX over n. So divided by the number. So Dr. Frost actually has a mnemonic for that. That's m. So that's mean of the square minus square of the mean. The book just says it, like memorize it like this. So yeah, mean of the square minus square of the mean. Standard deviation is just the square root of your variance. So it's just sxx over n in a square root or a radical. So again, the same concept could be used in frequency tables, just the way you could find variance in frequency tables. Again, this, oh sorry, I thought it was on highlight. This is given in your data booklet, but you need to know that standard deviation is radical variance. Coded data, so if I have, for example, my y equals x minus a over b, my mean is going to be my mean of y minus mean of x, equals mean of x minus a over b. So as you can see, my a and b still exist here. So you do everything, you just find the mean of this minus the constant over the other constant, okay? But for standard deviation, it's kind of different. So it's your standard deviation of y is your standard deviation of your original data, but you only divide, you don't add or subtract any constants. You only do division and multiplication when it comes to standard deviation. So now let's go with an example. So if set A has a size of n1 and then mean of x, and set B has size of n2 and then mean of x2, then the mean of them combined is going to be n1x1 plus n2x2 over n1 plus n2. Why is that? Because this is the whole numbers. So we know mean is sum of the values over the whole numbers. Like the number of numbers. And then this, you're basically finding the sum of them, the first data. So sum of A plus sum of B is going to give you sum of them combined, okay? So that's really easy when you actually see it. I think this model overcomplicated it, but still. Outlier is any value that's less than a multiple of your IQR plus, greater than a multiple of your IQR plus your upper quartile, or the same multiple of your IQR minus your lower quartile. What that means is basically if I have like a multiple of my upper quartile here, if I go less than my Q1, then that's going to be an outlier. And if I go above my Q3, the same amount, that's also going to be an outlier. So if you remove outliers from your data, you're practically cleaning your data, okay? On a histogram, what is a histogram? Histograms are like things like this. You have areas, you have class width, you have their frequencies, and you draw them like in cubes on a graph, okay? So to calculate the height of each bar, or like their frequency density, you should know that area of the bar is a constant times the frequency. You're usually asked to find this constant. How you do that is you compare two areas, or you compare your areas with your frequency to get the constant, and then you draw another bar on the histogram. Joining the middle top of each bar on a histogram forms a frequency polygon. When when they're asking you to compare data sets, you must always talk about measure of location and measure of spread. A stem and leaf we're going to talk about that more, so don't get confused. A stem and leaf diagram reveals the shape of data and enables quartiles to be formed. What is a stem and leaf diagram? It has a key like this. So 2-5 means 25. So then all of these values follow this rule. So like if I have 0.6, then it's 0.6, you know. Then if I have 4-1, it's 41. So whenever you're asked to draw stem and leaf diagrams, the most important thing to do is to actually start with a key and follow that key for all your values. And then you can compare two data sets using the back-to-back stem and leaf diagram. What is that? Basically, you choose the same key for them and you just write your values into comparison. So as you can see here, we could compare them with the shape of here, and we could say like, okay, this is more positive skewed, this is more negative skewed. We're going to talk about that later. A box plot represents important features of data, so you could find quartiles, you could find maximums, minimums, values, outliers, everything. Box plots can be used to compare data. So let's talk about a normal box plot. So this is my interquartile range. What does that mean? That means it's my difference between Q1 and Q3. And usually when I'm talking about a perfect box plot, I'm talking about the median and the mean to be on the center, so exactly between Q1 and Q3. And then if you move one interquartile after, or like here they said 1.5 times the interquartile plus Q3 and then minus Q1, you're going to have outliers after that. And exactly on that point, when you have 1.5Q or plus Q3 and minus Q1, you're going to have your minimum value and your maximum value, okay? So anything below the minimum, anything above the maximum is an outlier. Diagrams, measures of location, and measures of spread can describe the shape or the skewness of a data set. So how can we describe skewness? So you could use quartiles, you could use shapes from box plots, measure of location, and most importantly, there's a formula that says 3 times the mean minus median over your standard deviation. The greater that value is, the greater your skew is. And the opposite way around, obviously. So skewness, so if I had like no skewness, then my mean equals my median equals my mode, and I would have like a perfect shape, but that's not always the case. If I have a shape that's more bent to the left, my mode is here, my median is here, my mean is here, then I'm going to have a positive skewness because this is more bent to the negative side. And if I have something bent to this positive side, I'm going to have a negative skewness. A box plot of a symmetrical distribution is something like this. So Q2 is exactly in the middle. The whiskers of your box plot are equally spread out. But then if you have something more bent to the negative side, we already said it's a positive skew. So your Q2 minus your Q1, so this, is smaller than your Q3 minus your Q2. The opposite thing goes for here. If it's more bent to the positive side, yeah, I was checking if this is actually a negative skew, sorry. If it's more bent to the positive side, it's a negative skew. The exact opposite of this goes in. So chapter 4, Venn diagrams. I absolutely love this chapter. It's a very, very easy chapter. There's no reason why we can't get full marks with these questions, okay? So they represent data graphically. Mutually exclusive is probability of A or B, which is basically the probability of A plus the probability of B. So this plus this, okay? Independence is probability of A and B. So it's probability of A times probability of B. So they only want this middle section. So that's independent values. If you have a tree diagram, you should think of every single possible case. And then you show the outcomes of 2 or more events happening on succession. So you're acting like everything will happen. So if I have like a coin that I want to toss twice, once it could go on head, once it could go on tail, again once head, one tail. So head, 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 tail, tail, head, tail, tail is the only things that could possibly happen. And we are acting like, because it's like a fair coin, then therefore the probability of its landing head or tail would always be half. And the probability of something happening should always add up to 1. But we'll talk about that more later. So if I have A and B, and this is my my symbol, that's intersection. And remember this by like a clause of a claw machine. It only wants some specific thing. You cannot have everything together. You claw it, you choose it, and you take it. So that's this part. But then if you have A or B, it's union. It looks like a U, so union. And union is basically a ball that fits every single thing in it. So that's both and both. If you have something not A or A complement, then if this is A, you want only this part, not even their intersection. Probability of B occurring given that A has already occurred looks like this. So probability of B occurring given that A occurred. How do I remember this? I say B over A. So I see this symbol as over, and then you're searching for whatever, so all of A and whatever B A has in it. We're going to talk about that more. Just remember that. So for independent events, practically, because they're two completely different things, get probability of A given that B happened equals probability of A given that B did not happen, which just equals the probability of A, because they genuinely do not have any relationship. And the opposite thing goes again. So addition rule, this is actually given in your formula booklet, but unfortunately I don't like how they wrote it, so I just say memorize it. You don't even need to memorize, just understand it. So if I have probability of A union B, that means probability of A plus probability of B minus their intersection. Why that is because if I, for example, I do this as A and then this as B, if I was adding them, I'm adding this middle section twice. But then because I don't want to, I just subtract this middle section once from them. Conditional probability, given that A happens given that B happened. So that's basically written like this. So we already talked about the fraction bit. So what did I mean by the fraction? So I meant whatever is in B, and then on the on the top, you have their intersection. So everything that A it has in B. So if I have this is my A. So all of A over that section that B is in A. Multiplication rule. Let me check if we have this. We do absolutely have this in the data booklet. So let me make it green. So this says the intersection is probability of A given that B happened times probability of B. Already we know that that's just a rearranged version of this, right? Because you're multiplying this by this. So it's just rearranged. But again, know it. They're independent if probability of A times probability of B gives you your intersection, so it gives you this part. We talked about this at the very, very beginning. Mutually exclusive means one does not affect the other at all. So their intersection is going to be 0 because they don't even touch each other to intersect. Chapter 5. All of this, absolutely exactly this, word by word, is given in your data booklet under correlation and regression. Okay? So you just need to know this. We already talked about this. This is the exact same thing. You just put y values in it. And S of xy is just your sum of your x minus the mean and your y minus the mean of y, which is basically your sum of your xy minus sum of x times sum of y over n. N is the total number, not number of x's, not number of y's, not total number of x and y's, okay? Independent or explanatory variable is one that's set independently from the other values plotted on the x-axis. So it's plotted on this, and it's independent. It has nothing to do, okay? Dependent variable is a response variable. So values are determined by values of independent variable. It's plotted against the y-axis. So if I have 1, 2, 3, and then I change something, then these values on my y-axis are going to change. So for example, they're going to increase, okay? So the equation of a regression line of y on x, why is that? Because we are practically talking about the gradient here. So this is also given on your formula booklet. Okay, a better version of it is given. So if we imagine that y equals a plus bx, then b is s of xy over s of xx. This is definitely given. And a is your mean of y minus b times mean of x. This is also given. So coding is used to simplify calculations. Interpolation is estimating a value of dependent variable within a range of data. So if I have 1 to 10 for meters, if I want to see how many meters it goes for 6.4 meters, then that's interpolation because it is within the range. Extrapolation is estimating a value outside the range. It's unreliable because you're guessing, you're predicting. This is given in the data booklet. So R practically is your measure of linear relationship. So you could have a R equals 1 is like a perfect linear correlation. -1 is a perfect negative linear correlation. R is 0 means just no linear correlation. And R is not affected by coding. These are some examples you might want to see. So this is strong positive correlation, weak positive correlation because points are not really close to the line. This is a strong negative, weak negative, moderate negative because you could see that some are really close, some are not. And then this is just no correlation. Chapter 6. For a random value of x, the small x is a particular value of x, where small x is a particular value of x, probability that the big X equals the small x is the probability of x that refers to the probability of x being equals to x. That was very confusing, I am not going to lie to you, but that's how the book wrote it. We have simple explanations for it. So basically, if I have a coin, I have the probability of head and the probability of tail, right? So if I wanted tail, then the probability of tail is why am I writing it like this? So the probability of, oh my god, the probability of tail just equals the probability that the x that I want equals my tail. That's just it. Discrete random variables. So sum of all the probabilities add to 1 because they're discrete. You cannot add to them. They are not continuous. So all of the probabilities add to 1. Okay, and that's how you write it. Expected value. So if x is expected of probability of x, then my sum of all my xp's is going to be sum of the bigger x equals the mini x, which is going to be sum of my xp's equals x. That's just basically adding up whatever probability you have. For example, we're talking about the coin problem, it's adding up all the probabilities you have to like see how tail would come up. So that's just 0.5, you know. Because it's a ratio and we're acting like it's a fair coin, then it would always remain 0.5. But then that's your expected value. When you actually do it, you might have different values. Like you might have a coin that never actually lands on tail. Okay, so variance is, again, the mean of the squared. So you square it, you find the mean, and then minus the mean, and then you square it. Conditions for discrete uniform distribution. What does discrete uniform distribution mean? You have a constant number of values, and then you have them equally spread out. Example, the coin I just talked about. So discrete random variable x is defined over a set of distinct values. So you cannot add to it. It's not continuous. Like if I have a coin, I cannot have 3 sides on a coin. That's just impossible. Each value is equally likely. So the coin would only land on tail half the time, only land on its face half the time, you know. For discrete uniform distribution, x over values of 1, 2, 3 all the way to the n, you could find the expecting value of x to be n plus 1 over 2, and you could find the variance. Remember, you need to memorize this formula. It's not given. It's n plus 1 times n minus 1 over 12. I don't know how this came about, but you just really need to know it. Chapter 7. Total area under a normal distribution curve is always, no matter if it's dated, no matter if it's coded or not, it's always 1, okay? Normal distribution is perfectly symmetrical, no matter if it's coded, no matter if it's the original one, standardized, it's always perfectly symmetrical. So that means if I have like something like this, and this is my x, this is my z, the probability of more than z and the probability of then less than z is always going to be a half and a half, because z is exactly in the middle and they always add up to 1. So the probability that z is smaller or equals to a is defined by that symbol of a, okay? Again, not given, just memorize it, please. You can use its symmetry to find probability that a is smaller than 0. How you could do this is 2 ways. So if I have, let me choose a color, let's go with pink. If I have something like this on my normal distribution, I know that full area is 1, right? So if I want, and this is my a. So I could go 2 ways with this. I could either go the probability of a is smaller, a is bigger than z, so I could calculate the area up to here, or I could calculate this part and then say 1 minus this equals this. Both of them are very true, okay? Random value of x, normal distribution, but mean of this, and deviation of this. That just means how we write it. So we write x is almost n times this mean and the standard deviation. But when I have standard deviation squared, that just means the variance. So if I have something like this, you get your original data minus your mean over your standard deviation to give you your new data. So just memorize this. Let me check if it's in. But I just gonna say, okay, if I want something new, then it's my new, and then x minus mu. So it's your mean and over your standard deviation. But let me just check real quick. And unfortunately, it's not given, but it has given you the how you write it. So this part is given, but let me highlight everything. This part is not, so please memorize. Approximately 68% of the data lies within one standard deviation of the mean. 95% of the data lies between two standard deviation of mean. Nearly all of them, or 99.7%, lies within 3 standard deviations of the mean. Definitely memorize this. This is really, really important. They expect us to know, and they only mention it like a few times. So please, please, please memorize this. It would never go wrong. I've seen it come before. Oh, and that's it. It was actually not that long. So guys, as always, please, please, please do a lot of past papers. We still have time. Look at the mark schemes. Memorize some of the questions you don't understand because they keep repeating. If you have like a three past papers for S1, and if you compare them, the questions are really, really similar. Only the data value changes. So yeah, best of luck to all of you, practically everyone who's gonna do that exam. I know we're gonna rock it. If you guys had any questions, please comment down below. If you guys wanted any videos, please comment down below, and have the best day ever. If you didn't get a concept while I was explaining it, I used the book notes, so you could just go to YouTube, search it, watch it until you get it, and then do as many past papers as possible. Love you guys. Take care.